So, very good morning class. Today we are going to talk about information security. As you know, tons and tons of money is pumped up for information security. So, one thing which is very critical for information security is why we need to secure our assets. So, we need to first of all think about what are those assets, how the security can be given to those assets, and what is the role of information security professionals in today's era. Because as we know, the next war which is going to happen will be a cyber war. Everything will happen on the information security front. So, today we are going to talk about what are the characteristics of a secure system, why we need to have a secure system, what is the root cause of security problems, and how to eradicate one such problem called buffer overflow. Now, as you can see on this screen, so I am drawing a triangle having these three vertices. One vertex is functionality, the second vertex is ease of use, and third vertex is security. Now, as you can see, when a developer develops the program, he has in mind what kind of a functionality is to be given to the program, or whether I have to give a ease of use to the user, much more importance than functionality, or I have to give much more importance to the security. Now, just take an example. If I put much of more effort on a security part, so what may happen that I will lose out on functionality and ease of use. Let us take an example of Linux operating system. Now, this Linux operating system is pretty popular, but if you go to a user databases, most of the users which are not very technical would prefer to work on Windows than Linux. Why so? Because when the Unix was developed, most of the time the emphasis was on a security realm. So, the people were missing out at some kind of functionality and ease of use. So, that means now more and more people can adopt Linux provided it has ease of use also implemented, which is now being done. Like you have a Ubuntu. Now, in Ubuntu or another kind of environment, what is happening? We have a X window desktop, which is as easy to use as is being done in the Windows platform. So, that means the developer has to put equal emphasis on functionality, security, and ease of use. Now, let us take an example. What is the root cause of this? Now, if we have, let us say there is Mr. A and he has purchased a brand new operating system. So, when I say purchased, that means this guy has paid money in order to get the operating system. He has not pirated it from somewhere. So, now what happens once this guy has purchased and paying, let us say 10,000 bucks from his pocket in order to purchase the operating system. Now, let us say when he was installing the operating system, all of a sudden his D drive, which was his second drive, it got formatted. Somehow we do not know what were the reason for that, but it got formatted. So, what is the first reaction of Mr. A? Definitely he is going to call up a call center number of that particular company from where he has purchased the operating system. Now, there would be a lady who picks up the phone and which is a call center. So, she picks up a phone and asks this guy what is the problem. Now, Mr. A explains that, madam, I purchased your operating system paying 10,000 bucks, but now what has happened? It formatted my D drive. Now, what this lady can do at that point of time? She is only going to count the number. So, she assigns a number CAN 1, that this is a candidate 1 who has reported this kind of a problem with the operating system. And she is going to do nothing, but only she is going to counsel that particular guy that, okay, we are going to find out, figure it out that what is the problem with our operating system, and we will come back on this at a later point of time to you and give you some solution. Now, what happens down the line? Let us say on that particular day itself, after few hours, another call comes from other part of the world and this guy also says the same thing, that I was installing your operating system, I purchased it, and now while installing my D drive got formatted. Now this lady says now count has gone to 2, from count 1 to count 2. Now this problem is going to happen again and again and again till the count reaches a threshold value. Let us say that threshold value is 20. Now when the same thing is reported by so many people across the world, let us say the count is 20. Now in that case, what is going to happen? A meeting is being called for all the developers of this particular operating system, and this is reported to them that this is a serious thing which is happening. This is not misconfiguration by some user, but actually this is a problem with our operating system. Now all these developers sit together and try to find out, first of all they are going to mimic the same situation. They are trying to figure out that whether this was actually done by the operating system or some misconfiguration might have happened at the user end. So they mimic this particular solution, and they found in fact the operating system is doing this kind of a mischief. Now what they are going to do, either they are going to release a hotfix or they are going to release a patch. Now what is the difference between hotfix and patch? Hotfix is when you apply this particular solution to the operating system or any other environment, there is no downtime. That means while the operating system is running, it is in a production mode, I can apply the hotfix and the problem goes away. Whereas patch, whenever I apply a patch, there is a downtime associated with it. That means system need to get rebooted, and then the configuration part will come up and the system will get eradicated by that particular vulnerability which was previously existing in the system. So patches cause a downtime, whereas hotfix does not have a downtime, and it depends upon a vulnerability. If the vulnerability is pretty serious, it may have 1, 2, 3 patches which will get released and then published by this operating system vendor, that these are the patches available for this version of operating system, and once this operating system is patched, then it will get rid of that particular vulnerability. Now what happens when the patch or a hotfix gets released? This particular information becomes public through something, through a number which is called CVE number, and CVE stands for common vulnerabilities and exposures. And this common vulnerabilities and exposures are given some kind of a number, like 2016 a new vulnerability 001 is found in operating system A, B, C. So in that case CVE 2016-001 will be published publicly, and each and everybody on this earth would know that this kind of a vulnerability exists in this particular operating system. Now the problem is, once these vulnerabilities are published in a public databases, now these are also available to the hackers. Now these guys can go into the vulnerability listing and find out why this vulnerability happened, what is the root cause of it. And once they find the root cause, they might develop something which is called an exploit in order to exploit this vulnerability, and then make this exploit publicly available, so that whosoever has not patched his or her system with this CVE 2016-001 and is vulnerable can get exploited by this particular exploit. So there are n number of cases which are available throughout this generation of software development, which are going to highlight that there are certain vulnerabilities which are existing in all kind of operating system, in all kind of devices which are governed by softwares. And now it is becoming very, very difficult in order to patch this kind of a system, because complexity is increasing, and as these softwares are going to deal with the real time problems, in order to patch this vulnerability, it is pretty crucial that we act now and produce either a patch or a hotfix. Now let me give you a few examples from where you can understand that what kind of after effect a software vulnerability can have on a system. Recently, there was a vulnerability which was discovered in a car system, and this car system was from one of the major vendors. And what was happening, this car was not able to, the sensors which was built in a car were not able to differentiate between whether a adult is on a seat or a kid is on a seat. And once it is not able to differentiate, those sensors were not able to differentiate, what was happening? The airbags were not getting opened when there was a smash of a car happening against something during an accident. So it may cause a loss of life. So this is a pretty dangerous affair. Let's take another example. Recently, one of the players in Indian team was treated for cancer, and this guy was given a chemotherapy, and this chemotherapy was given by not just doctors, the doctor instructed a machine to give chemotherapy. And as you know, this kind of a chemotherapy goes to a patient for, let's say, more than 1 minute if it is given to a patient, and the patient body is not able to receive it in a proper fashion. So it may so happen that the patient dies on an operation table itself or a chemotherapy table itself. So that means if there is a bug in that particular system which is driving this chemotherapy machine, so it is pretty critical that the loss of life may happen. Another example could be, today we are witnessing so many computer automated systems which are available, like you may take an example of SCADA system, which is called supervisory control and data acquisition systems. Now these systems are controlling nuclear power plants, our power grids, and they are going to do a load shedding. Whenever they find that there is a load on a particular line, it gets shifted automatically to another line. Now as these systems are controlled by software, now if there is a bug or a vulnerability which is existing in these systems, it can lead to a trouble. And that kind of a trouble can make the whole city go out of power. And this kind of news you might have seen that almost 2-3 years back there was a newspaper headline which said that for 2 hours there was no power in a particular city in US. Now why that was so much of hue and cry? Because each and everything is now controlled by these systems, and these systems are controlling this based on a software. That means whenever we are developing a software, it is the moral duty of a software developer that he must know that what kind of instructions are to be embedded, and he must check these instructions against some test cases so that he can be sure of that whatever software is getting released to the public, it is having no vulnerability as such. So, but that kind of a surety is not possible, because there are certain things which are out of bound for even developers. Like for example, a particular vendor A, he releases a software called, let's say, a web browser, and this web browser is out to the public and so many people are using it. Now all of a sudden there is a vendor B, he also wishes to put his web browser out in the public so that the people can start using his web browser rather than the company A's web browser. So he comes to his developers team and says, tomorrow we have a date of release, so kindly release this web browser. Now even the web developers are going to say, no sir, there is still some work which is pending, but this guy is going to say, no, I want this particular product to be out in the market tomorrow. So what is being done? That means this is a marketing pressure which is happening to a company which is trying to push this product into the market, though this product may not have been fully tested, but still it is now out in the market. Now when there are so many hundreds and thousands of people are using this product, they may end up in getting a product which is not fully tested, and this kind of a vulnerability may lurk in that software which can later be exploited by the hackers. Now, one such vulnerability which is very popular amongst the whole world, and we have seen almost a decade long possession of this particular vulnerability on the top 10 vulnerability list, and this vulnerability is called buffer overflow. Buffer overflow. Now, let us concentrate on what is buffer overflow. Now, whenever we are running a program, let us say I am going to give an example of a C program. So, we usually write a function like int main, and then we say int argc. This is the arguments which we are going to pass at a command line parameter, and then we say character star star argv. So, this is a command line array which is going to point to those parameters which are going to pass to this function from a command line. Now, inside this function, let us say I have declared a character buff, and it is going to take, say, let us 10 characters, and then I am going to call a string copy function strcpy and copying into this buffer a argument first, which is the first argument which can be passed to this function, and then we have usually a return. So, once we are returned from this function, see what is going to happen. So, actually a static memory is getting allocated to this function because I have declared an array, and this array is called buff. So, this buff array can take 10 characters. Now, these 10 characters are taken from the first command line parameter. Now, if there is a guy who knows that after 10 characters this program buffer may overflow, because that is the limit which is being described in the program. Now, when we run this program, if we try to put more characters into the program, then can be accommodated by this program. So, this buffer overflow will happen, and this buffer overflow can then create a problem for my system. Let us see an example by running it and seeing what happens to my buffer when I run such a program. So, I am going to go to a directory called demo, and now inside this directory I have a file called stack overrun.c. Now, as you can see this stack overrun.c. Now, I am going to print some values from the stack into this program. So, initially my stack looks like this %p %p. So, I am going to really output 13 stack values, that means 13 addresses from the stack are being outputted. After that, I am going to copy a input which is my first argument to the program, and it is going to go to the buffer using a function called string copy. Now, as you can see, I am not putting any bound here. That means I am not binding a user that you can only send 10 characters to my program. So, this input can be as lengthy as it can be by an hacker. Now, if this is going to be pretty lengthy string, what is going to happen? It is going to cause my buffer to overflow. Now, once this buffer gets overflown, so I may then craft a special buffer where return address of the main will be, and I can take hold of that address and hijack the control flow of a program. Now, as can be seen here, I have two functions. One function is called foo function, in which I am going to print the values of stack, and there is another function which is called a bar function, and which only displays a string which says I have been hacked. Now, if you go into my main program, you just see, you can see here nowhere I am going to call a bar function. That is pretty interesting. So, bar function is defined inside a program, but I am not calling it. So, is it possible to call this function out of a blue by sending an address of this function as part of my buffer? And if this can happen, this would be a very interesting thing to happen. And from a developer point of view, if I know that this can happen, This is my moral duty to stop this from happening. And this way we can, whatever function or software we are going to develop can be secured from this buffer overflow attack. But in order to do that, I must know that which function is going to cause this disaster. And if you see here, this function is called string copy function because it does not ask a user to bind the input to something. And this is principally operation of a computer system, where computer system works on a principle called GIGO, garbage in, garbage out. That means if input is not okay, the output is going to be a trouble. And that same thing is happening in this program, because we are not controlling the input part, the output part is going to be a disaster. Now, as you can see here, the first thing which is going to happen in this program is, if argument C is not equal to 2, that means I am going to say please supply a string as an argument. I am asking the user to input like this, and then I am calling a function and passing this parameter to a function called foo. Now, once it goes to a foo, I have declared a buffer which takes 10 characters, and then I am doing a string copy and printing the stack. That is it. So, this program nowhere is going to call bar function. But when I run this program, let us compile this program and run. So, what I am going to do here, I am going to open this program, and this program we are going to run from a demo directory. So, we have already created a demo directory, and this is a program. I am going to open this program and open with dev C++ IDE, and I am going to compile this program. So, I say execute compile. So, once I compile this, as you can see, it has created a stack overrun.exe file in the same folder where this C file was there. So, if you see dir star.exe, so I have a stack overrun.exe file here. Now, let us run this. So, I run this stack overrun, stack overrun. So, now it is printing two addresses. One is the address of a foo function, second is the address of a bar function. Now, as you can say, foo function is at 4014F0. This is a hexadecimal value, logical address of this in a RAM in the computer memory, and bar function is situated at 401551. So, these addresses are pretty interesting. So, when I will be crafting my buffer, so I will explicitly mention this address, so that this address can be called from function. So, it says please supply a string as an argument. So, I am going to supply that argument now. So, I say hello. So, that is it. So, when I said hello, so because hello is less than the buffer value, so it is going to print everything as was done in the program. So, it is going to print these 13 values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 initial stack, and once the hello is pushed on a stack, this again prints those values. Now, if you can see here, it is HELLO, this particular line which I am highlighting here, so that you can understand where the hello function, hello string is being pushed onto the stack. Now, if I am going to increase the size, see what is going to happen. Let us do this way. So, I am going to say stack overrun Maninder, which is 8 characters long, and again I say Maninder, which is again 8 characters long. So, what is going to happen? So, I see there are two locations which are filled with Maninder and Maninder. That means still, even if the buffer has overflown, I have not reached the return address of this function. So, what is to be done in this case? I need to send again a string which is much more than this particular value. Let us say again I am going to send Maninder. So, once I send this, now you can see it is saying the stack overrun exe has stopped working. A problem caused the program to stop working correctly. Windows will close the program and notify you if the solution is available. Now, this is a golden day for an hacker if this kind of string is being displayed on a screen. That means this program actually has crashed, and this crash is going to give me leverage where I will be able to now craft a particular buffer and take control of EIP. Now, in order to do that, I need to understand what EIP is. Now, EIP is called instruction pointer, extended instruction pointer. This is a register in CPU which actually points to the address of next instruction, which is to be executed. Now, if this EIP gets overwritten, like in our case, let us say there is a string called Maninder, and out of that the 4 characters MANI are overwriting EIP. That means in memory, now EIP will be pointing to an address which is actually hex equivalent of MANI. So, that means this is an arbitrary address. Let us say if I send a 4 A's to this program. So, this will be 41, 41, 41, 41. So, that means the next instruction which is going to get executed will be at 41, 41, 41, 41 address. Now, this instruction 41, 41, 41 does not actually exist in memory. So, my program is trying to access memory location which is 41, 41, 41, 41, but this is access violation. What I mean by access violation? See, when the program runs, it runs inside its own memory. So, it is not allowed to go out and access somebody else's memory space. So, that means program is binded to access its own memory location. Now, if we say 41, 41, 41, it appears to be a memory area which does not belong to my program. So, that is why the access violation will happen, that my program is trying to access memory which is not actually part of this program. So, in this case what needs to be done? So, instead of this 41, 41, 41, if we can send a legitimate instruction which is existing in the memory and is accessible by my program, then this access violation error will not come and my program is going to get executed smoothly, but also it will point to an address where I have a malicious code available. And once it gets executed, I may be able to conquer your machine, and that is very dangerous affair. That means by use of a buffer overflow vulnerability, if it exists in a program, I can eventually cause a program to do something else than doing the actual work. Now, let us see it by example. Now, we know that this string Maninder, Maninder, Maninder is going to cause a crash to the program. So, what I am going to do? I am going to write a small Perl script where I am going to send this particular string, and we already noted the address of this buffer bar, a function bar, and this address is I am highlighting, address of bar is 401551. So, I am going to supply this as part of an input. Now, once this input is given to the program is going to execute the bar function. That means, bar function is available in the memory and it can get executed even if the main is not going to call it, and that is how dangerous it can be. Now, let us write a small Perl script. So, I am going to open a notepad, I say hack.pl. Now, you see here what I am going to do, I say argument is Maninder, 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 and these are the things which I am going to pass to this particular variable called arg, and then concatenating it with 51, 15, 40. So, we have to write it in a reverse order because it is in a little endian format. So, there are two formats which are available. One is called big endian format, another is called little endian format, or we can say network byte order and host byte order. So, whenever a data is getting transferred from a host to the network, it needs to get converted from host byte order to network byte order, and vice versa when it is being received by the client or a server. So, when the client or server is going to receive back the data, it must get converted from network byte order to host byte order. Now, why this happens? And now the modern programming languages have already abstracted this functionality and user is not worried about it. So, but if we are going to go into the core part, then we need to do this kind of a conversion. Like if I am writing a program in C language, I must do this kind of conversion. But if I am writing this program in Java or Python, it is not required, because these languages already know that how this conversation is going to happen. So, they provide the function which are going to do this conversation. But now in this case, we are going to supply this particular thing as an argument to the main function, and then we use a command called system which is going to execute this particular command. That means when I am going to run this, now see what happens. I say stack overrun, and then I say Maninder, 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 and let us say I now send a address x40, x51, x15. So, it says it has caused a trouble because it is not going to, but my function also does not get executed. But when I take help of Perl script, now let us run this program. So, I say Perl hack.pl. Now, see what happens, though the program gets executed, it is going to call a bar function, you can see at this bottom. So, it says I have been hacked. That means out of a blue, bar function was called and this string was actually sent back from a main program, and this main program got the input from a user from the command prompt, and this is how it got hacked. That means if something is there in the memory, it can be called by a program through input given to a program. Now, as we have seen in this program, which is demo, in a demo folder, we have already ran this program which is called stack run. Now, when I am going to call this particular program from a Perl script, I am specifying an address of bar function. That means as part of a input string, I am giving an address of a memory location which does belong to my memory area, my program's memory area. So, bar function is there. So, I am supplying the address of that bar function and this bar function is going to get executed. That means even if the main is not going to call it, but still this program can run, and that is very dangerous situation, and this dangerous situation is only caused because my buffer has overflown. And this kind of a programming know-how needs to be given to the developer in order to have a safe programs. That means whenever we are going to decide a buffer, so we must be sure that what kind of a function is going to be operating on this buffer. So, if we are using a string copy function, if we are using a gets function, put function, all these functions are dangerous in nature and these should be avoided as much as possible. So, that means we must first bound and then do the programming. So, if the bounded program is being given, it is much more beneficial as compared to non-bounded input which may come from the user. Thank you. So, in the next lecture we are going to talk about a real-time application which is called animated cursor vulnerability, which also is a buffer overflow in Windows environment. Thank you.